In this video, we will solve auxiliary equation with repeated roots of homogeneous differential equation with constant coefficient. So we're given by a problem of quantity d to the power 4 plus 3d cubed minus 6d squared minus 28d minus 24 times y is equals to 0. So just like before, as instructed by the book, we will assume if it's not specifically given what is the independent variable, we will assume it's x, and the dependent variable will be y. So that will be dy over dx. So first step in solving this problem is to convert this differential operator into an auxiliary equation. So that will be m to the power 4 plus 3m cubed minus 6m squared minus 28m minus 24 is equals to 0. So we will use synthetic division to find the roots of this equation. So to get the possible roots or to know the possible roots of this equation is we'll label the first term as our q and this will be our p. So all possible roots will be given as p over q. So that will be the multiples of negative 24. That will be positive negative 1, positive negative 2, positive negative 4, positive negative 6, positive negative 8, positive negative 12, and positive negative 24. So I will use negative 2 as our divisor in this problem. So I will use negative 2. So just copy the coefficients of our equation. That will be 1, 3, negative 6, negative 28, negative 24. So bring down 1. That will be 1 times negative 2. Be 2. Negative 2 plus 3. That will be 1. 1 times negative 2 will be negative 2. So negative 6 plus negative 2, that will be negative 8. So negative 8 times negative 2, that will be negative or positive 16. That will be 16. So it will be negative 12. So negative 12 times 2, that will be positive 24. Plus negative 24 is 0. So therefore, our first root, that will be m sub 1, is equals to negative 2. So the answer of our synthetic division will be in an equation with reduced order. So that will be m cubed plus m squared minus 8m minus 12 is equals to 0. Find the roots of this equation. So just like before, p over q. So the multiples of negative 12 will be positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and positive negative 12. So I will use negative 2 again as our divisor. So just copy the coefficients of our equation to be 1, 1, negative 8, and negative 12. So bring down 1. 1 times negative 2 will be negative 2. Negative 2 plus 1 will be negative 1. Negative 1 times negative 2, that will be positive 2. So that will be negative 8 plus 2. That will be negative 6. So negative 6 times negative 2 will be positive 12. And 12 plus negative 12 is 0. So therefore, our m sub 2 is negative 2. So we will turn this answer of synthetic division into a quadratic equation. That will be m squared minus m minus 6 is equals to 0. So the factor of this equation is m sub or m plus 2 and m minus 3 is equals to 0. For m sub 3 now will be negative 2 and our m sub 4 is equals to 3. The final answer or the solution of auxiliary equation with repeated roots is written in the form of y is equals to c sub 1 e raised to mx plus c sub 2 x e raised to mx plus c sub 3 e raised to or c sub 3 x squared e raised to mx plus c sub 4 e raised to or c sub 4 x cubed e raised to mx. Plugging in our roots. So we got 3 repeated roots and 1 distinct root. Plugging in our first root, that will be c sub 1 e raised to our first root is negative 2. So it will be negative 2x plus, because it's repeated, we will add x. So c sub 2 times x e raised to negative 2x plus c sub 3 x squared e raised to negative 2x plus our distinct root, that will be 3. c sub 4 e raised to 3x. So simplifying this, so y is equals to, we will factor the e raised to negative 2x, that will be c sub 1, quantity c sub 1 plus c sub 2x plus c sub 3x squared multiplied to e raised to negative 2x plus c sub 4 e raised to 3x. So this is our final answer. So problem number 17. So quantity 4 to the power of 5 minus 23d cubed minus 33d squared minus 17d minus 3 multiplied to y is equals to 0. And just like before, we will assume x as our independent variable and y is our dependent variable. So that will be dy over dx. So the first step in solving this problem is to convert this differential operator into an auxiliary equation. So that will be 4m to the power of 5 minus 23m cubed minus 33m squared minus 17m minus 3 is equals to 0. To get the roots of this equation, we will use synthetic division. And in order to find or to know the value of our roots, we will label this first term as our q and the last term as our p. So to know the possible roots, it will be p over q is equals to the multiples of 3, that will be positive negative 1, positive negative 2, positive negative 3, all over the multiples of 4, that will be positive negative 1, positive negative 2, and positive negative 4. So copying the coefficients of our equation, that will be 4, 0, because we don't have m squared. So the value of our m cubed, that will be negative 23, and that will be negative 33 minus, or negative 17, and negative 3. The divisor I will use is 3. So 3. Bring down 4. 4 times 3, that will be 12. So 12 plus 0, that will be 12. And 12 times 3, that will be 36. So 36 plus negative 23 is 13. So 13 times 3 is 39. So 39 plus negative 33 is 6. So 6 times 3, that will be 18. And 18 plus negative 7 is 1. So 1 times 3, that will be 3. So 3 plus negative 3 is 0. Therefore, our m sub 1 is equals to 3. So the answer of this synthetic division, it will be written in the equation with reduced order. So that will be 4m to the power of 4 plus 12m to the power of 3 plus 13m squared plus 6m plus 1 is equals to 0. To know our root, that will be for p over q is equals to the multiples of 1. That will be positive negative 1 all over positive negative 1, positive negative 2, positive negative 4, the multiples of 4. I will use negative 1 as our divisor. So copying the coefficients of our equation, that will be 4, 12, 13, 6, and 1. So bring down 4. 4 times negative 1, that will be negative 4. So that will be 8. 8 times negative 1 will be negative 8. That will be negative 8 plus 13 is equals to 5. So 5 times negative 1 will be negative 5. And negative 5 plus 6 is 1. 1 times negative 1 is negative 1. And negative 1 plus 1 is 0. Therefore, our m sub 2 is equals to negative 1. We will write this quotient into a reduced order of equation. So it will be 4m to the power of 3 plus 8m squared plus 5m plus 1 is equals to 0. I will use negative 1 as our divisor. So negative 1. And just copy the coefficients of our equation. That is 4, 8, 5, and 1. So bring down 4. 4 times negative 1 is negative 4. Negative 4 plus 8, that will be 4. So 4 times negative 4 is negative 4. Negative 4 plus 5 is 1. So 1 times negative 1 will be negative 1. And negative 1 plus 1 is 0. Therefore, our m sub 3, or our third root, is negative 1. This will be written in the form of quadratic equation. So that will be 4m squared plus 4m plus 1 is equals to 0. So I will use quadratic formula to get the root of this equation. So that will be x is equals to negative b plus positive negative square root of b squared minus 4ac all over 2a. So plugging in the value, so that will be x is equals to negative b. Our b is 4. So we will get first the positive root, that will be plus square root of b squared, that will be 4. 4 squared minus 4. Our a is 4 and our c is 1. All over 2 times our a is 1. So plugging this in our calculator, we get negative 1 half. So it will be negative 1 half. So this is equals our fourth root. Getting the negative root now will be negative b. So our b is 4 minus square root of b squared, that will be 4 squared, minus 4 times our a is 4 times our c is 1. All over 2a, that is 1. So our x sub 2 equals to negative 1 half also. So this is equals to our last root, or the m sub 5. All our roots, so that will be our m sub 1 is 3, m sub 2 is negative 1, m sub 3 is negative 1, m sub 4 is negative 1 half, and m sub 5 is equals to negative 1 half. The solution of auxiliary equation with repeated roots is written in the form of y is equals to c sub 1 e raised to m sub 1x, because we have distinct root. So that will be n sub 1x plus our two groups of repeated roots. So that is equals to c sub 2e raised to m sub x plus c sub 3x e raised to mx plus c sub 4 e raised to mx plus c sub 5x e raised to mx. So plugging in our roots, that will be y is equals to c sub 1 e raised to m sub 1x, that's 3x, plus our c sub 2 e raised to negative x, so it will be negative x, plus c sub 3x e raised to negative x, plus c sub 4 e raised to 1 negative 1 half x, and our c sub 5 x e raised to negative 1 half x. So simplifying this equation, that will be c sub 1 e raised to 3x plus quantity c sub 2 plus c sub 3x multiplied to e raised to negative x plus c quantity c sub 4 plus c sub 5x e raised to negative 1 half x. So this is our final answer.